In this and the next several videos, you are going to learn all about polynomials and working with polynomials in Python. I am super excited about these videos, not only because I'm super excited about all the videos in this course, but because polynomials are really great. First of all, the word polynomial is a lot of fun to say, but also polynomials are really important in math. They're important in applied mathematics, are important in engineering applications, and they're also important in more abstract math. Polynomials have lots of great qualities. They're all over calculus, and anyway, I could go on and on. So what is a polynomial? What are these amazing, amazing things? A polynomial is an expression that has a form that looks something like this, where you have some numbers that are called coefficients multiplying some variable, and here it's called x, raised to higher powers. So a0, a1, a2, all the way up to an. These are just individual numbers. Maybe this is 6, or maybe this is 3.2. And the x is some variable, and you can see that the variable gets increased to higher powers. Now, the number of total powers, so the highest power of x, or whatever the variable is called the order of the polynomial, or it's also called the degree. In fact, I think in Python it is called the degree, not the order. So this would be an nth degree polynomial. Okay, so here you see a couple of examples, 2 examples. So here the coefficients are 3 and 5 and 5, 6 and 12.4, and you can see that the degree or the order of this polynomial is 3. Here you see another example. Now, polynomials don't necessarily need to have every single power that you can see here. So there is no a0 here. There's no individual number not attached to the x, and there's also no x squared in here. Still, this is a third degree polynomial, or a degree 3 polynomial. So that's what a polynomial is. What you are going to be doing in this video is learning about adding polynomials to each other. So this is one polynomial, this is the other polynomial that I showed on the previous slide. And now, how do you add these things together? Well, it's pretty straightforward. What you have to do is look for all of the like terms. So you look for the terms that have the same degree or the same power on the x, or whatever the variable is. So for example, minus 5x and plus 2x, so these can be combined into minus 3x. And then over here we have 12.4 x cubed and just regular x cubed. These are both positive, so you add these together, that becomes 13.4 x cubed. So the end result of the addition of these two polynomials is this number. In this video, we are going to be using the SymPy module as well as the display and math function. So I'm already importing all of these things here. Okay, so we are going to need a symbolic variable. How about we use x? I've already explained before that I happen to be fond of the letter x. Okay, so let's come up with a first polynomial. So how about 2 times x cubed plus x squared minus x? So that is our first polynomial. And then the second polynomial will be x cubed minus x to the 4th minus 4 times x squared. Squared. Okay, so let's start by printing. How about just p1, polynomial 1? All right, so this seems fine, but doesn't look really nice. You know by this point in the course that I like to print these out to make them look nice. So display math, and now we need to convert this into LaTeX. All right, this looks pretty good. And now let's also have a quick look at P2, polynomial 2. So there you go. Now notice that SymPy is actually reordering the polynomials to put the terms with the largest coefficients, the highest powers, to be in the first position. So here I wrote minus x to the 4th in the second term, and SymPy just rearranged it to have the highest power coming first, and then decreasing powers as we go along. So now let's see what happens when I write p1 plus p2. So notice that these two terms, actually, you know what's even a better idea? I'm going to write this out. I'm going to write out the whole thing. So let's say math percent s plus %s equals %s. Okay, and now I'm going to replace this with a bunch of LaTeX code. So this is going to be sim.latex for P1, and then sim.latex for P2, and then the addition of them. Oops, right, no comma over here. All right, this was a mistake. I hope you caught that before I did. That should be P2, not just the number 2. All right, so here it's kind of hard to see what was polynomial 1 and polynomial 2. So actually, let me put some parentheses around here. These parentheses, of course, are not mathematically necessary. They're not necessary for code. They are only here for ease of visual interpretation of the equation. So here's polynomial 1, polynomial 2, and their sum. Now notice that there's only one term here that is to the 4th power, and there are two terms that contain x cubed, and that's x cubed on its own, and then 2x cubed. So you add those together, and you get 3x cubed. All right, and then we can also subtract them. So I'm going to say minus over here, and of course we need a minus over here. And now we get a different result. In particular, this is now just x cubed, because this is 2x cubed. This, you always have to be mindful with these minus signs here. So this is plus x cubed, but then there's a minus sign that applies to the x cubed term here. So this is one way to create polynomials in the SimPy module. I want to show you another way, because this is going to turn out to be pretty useful for some applications, in particular for the exercise at the end of this video. So I'm going to use sim.poly, and then the input into this poly function will be the polynomial. So for example, how about 2 times x cubed plus x squared minus x? All right, so let's see what this thing is. First of all, I'm going to type to see what the class is. So the class of this variable is a poly. There's polys all over the place. So this is a polynomial. And let's see what this looks like. So you can see this is the function poly, and here's the function, and the main variable is x, and the domain is z, which basically just means that the coefficients, or these numbers here, are all integers. So you don't have to worry about the domain for now. All right, so what can we do with a poly class? So one thing we can do is substitute for x. Now, previously you learned how to do this, something that was like subs, but now with the poly class, it works a little bit differently. We can say p1.eval, and let's say 0. So that's a pretty simple one to compute in our head. So essentially we're substituting for x the input here, which is 0. So of course when x equals 0, we get 0 as a result. Another method that we can apply here is called p1, or the polynomial variable, coefs, without the 0. So this returns a list, and the numbers in this list are 2, 1, minus 1. So what could this possibly mean? Yes, I'm sure you guessed it correctly. These are the coefficients on the polynomial. So here is 2. Now you don't actually see the 1 in here, but it's here implicitly, 1. And here it's a minus 1 because I'm subtracting x. Now notice that the order of the coefficients is not the same as the order that they are presented in here. So for example, if I would say x squared, so if I put the x term first, and then the x term, the x squared term first, and then the x term, and then the x cubed term. Now the coefficients are the same, and that's because, as I mentioned up here, SimPy internally is going to reorder the polynomial so that the largest coefficient terms, or the highest order terms, are first. The exercise for this video is to first implement these polynomials, these 3, as a list in Python. So this is the first, the second, and the third. So implement these as a Python list, and then you have to loop through, and for each of them you have to calculate the degree of the polynomial, And if the degree is even, then you sum the coefficients. And if the degree is odd, then you count the number of coefficients. So for example, the degree of this polynomial is 2. So we would sum the coefficients. The coefficients are 1 and 2. So that would be 3. And here in this polynomial, the degree is odd because the largest term is x to the power of 3, so the degree is odd, and then we just count the number of coefficients. So in that case, the answer would be 2, although the coefficients are -1 and +4. All right, now I haven't actually told you how to compute the degree of a polynomial in Python, but I think you can figure it out by knowing that the term for this thing, the highest power, is called the degree. All right, so good luck. Now is your chance to pause the video, work through this assignment, and of course, I'm going to now switch to Python so you can watch me work my way through this. All right, let's see. So I'm going to start working in this cell. So the first thing that I'm going to do is create a list of polynomials. Let's call this polys. Remember, a list has these square brackets like this. Okay, so I'm going to make sure these are all of class poly, so that's sim.poly. And then that first one was 2 times x plus x squared. And then we had sim.poly. Poly. The next one was minus x cubed plus 4 times x. And then the third one was sim.poly. That was x to the power of 5 minus x to the power of 4 plus 1 over 4 times x plus 4. Now this term, just to be clear, this term was actually x over 4 like this. However, multiplication takes priority over division. Remember, the order of operations was PEMDAS. So multiplication comes before division. So in fact, writing it this way is the same as saying 1 over 4 times x. Although now that I see it written out, I think this is a little bit clearer. Okay, so ran this, we didn't get any errors, so that's a good sign. And now what we need to do is loop through these. So I'm going to say for pol I in polys. And then what do we want to do? So we need to extract the degree of the polynomial and determine whether it is even or odd. So it turns out that getting the degree is pretty straightforward. And in fact, I think I'll show it to you up here. So here was P1. And so the degree we know by just looking at this thing that it's a degree 3 polynomial. So I'm going to say print P1 dot degree, and that tells us that it's 3. Okay, so then we have poly dot degree. And now how can we tell whether this is an even number or an odd number? Now you might remember from a couple of videos ago I showed you how to use the modulus, or the remainder after division, to determine whether a number is odd or even. So that was the function in the NumPy toolbox called mod, and then divide by 2, and we test whether that is equal to 0. So that was a method that I showed previously, and this works. This is a great solution, and there's nothing wrong with it. However, I haven't actually imported NumPy, and I'm too lazy to import NumPy right now. So therefore, I'm going to show you a different approach, which is equivalent to this. Actually, let me leave this up here, and then I will show you this. So I can also say poly.degree, and then use a %2 equals 0. So these two lines are equivalent. The % is also computing the modulus, or returning the modulus after division by 2. Okay, so if this is the case, then that means that this number is even. And then when the number is even, we say the degree is even, and the coefficients sum 2, and then %g, and then we want the sum of the polynomial coefficients. All right, so this code is not yet finished. However, I want to run it already to see if we've made any mistakes or if we got the right answer. Okay, so okay, this was not intended. Sometimes I make these mistakes on purpose just to make sure you are paying attention. This was a careless mistake on my part. I didn't even put the if statement in here. All right, so this looks good. This says the degree is even and the coefficients sum to 3. So that part is kind of accurate, except we don't know which polynomial this was corresponding to. So we can see by looking at it that only one of them actually is even. So that part makes sense. But I would like to put the actual polynomial in here. So let's say the degree of, and then I'm going to say %s, and here I want to replace this with the expression. So I can do it this way. I can say poly. However, that's returning this really long thing. And actually, I only want this. So the method to extract just this part, just the actual polynomial, is dot as expr. So essentially, I'm converting this into an expression. So this polynomial object as an expression. All right, so the degree of x squared plus 2x is even, and the coefficients sum to 3. Great. So that is part of the solution, and then the other part is we have to say else. So if this is not the case, so if the degree is odd, then we want to print the degree of %s is odd, and there are some number of coefficients. All right, so then let's see, we want again poly.asExpr. And then the second one is we just want to count the number of coefficients. So there we can say len for length and then poly.coefs. Great. Oops, not so great. I'm missing a parenthesis on coefs. All right, so this is starting to look good. I'm going to say that this is now finished in the interest of time. But of course, if you would like, one thing you could do to make this look a little bit nicer without really changing the solution would be to get all of this to work in LaTeX so that you get a nice printing of the polynomial so it looks a little bit more like this. So in this video, I gave you a reminder of what polynomials were, and I introduced you to working with polynomials in Python and extracting information out of Python and adding and subtracting multiple polynomials. In the next several videos, we will continue on our exploration of working with polynomials in Python, and I look forward to seeing you then.